Hydroelectric power plant. In a hydroelectric power plant, electricity is produced from water. A dam is built across a large river to hold back the river water and raise its level to form a reservoir. At the bottom of the dam, there is a floodgate. Water flows through the penstock and rotates the turbine. The flowing water rotates the turbine, which is placed at the end of the penstock. The turbine, in turn, rotates the shaft that is connected to the coils of a generator. These coils are placed in between strong magnetic poles. The rotating shaft turns the coils.
Hi guys, welcome to howmachineworks.com. Today let's learn how a centrifugal pump actually works with the help of this animation. So let's identify all the components initially, then we'll see the animation and understand its detailed working. So let's identify the components. That's the suction strainer at the bottom where the water is being sucked in by removing the impurities or the foreign materials. Then that's the foot valve. There we have the sump where the water is stored. Then that's the suction pipe out there. Then that's the suction flange. We have the vacuum gauge over here. Then comes the pump casing. Then we have the eye of the impeller, the center of the impeller, and that's the impeller over there in blue. Then we have the delivery flange. We have the pressure gauge, then the delivery valve, and the delivery pipe over there. So finally the water reaches the overhead tank, which is over there, and that's finally the discharge level. So now let's see how it exactly works with the animation. Water enters through the suction strainer and it strains away the foreign materials and impurities, dust particles, etc. And it goes into the valve, the foot valve. The foot valve opens up when the pressure rises and the water goes to the suction line. So like this, and you can see the gauge moving. There's a vacuum gauge. If there's a vacuum pressure is shown over the vacuum gauge, right? And then the water reaches the impeller. Now let's zoom it and see how it enters the impeller. The eye end of the impeller is at the center, so it enters to the eye end. Then it goes to the impellers. So you can see the vanes of the impellers shown over there. So the water enters the vanes of the impeller like this, and it's distributed towards the casing, and that's how it travels. The initial travel happens. So you can see all the diameter or the distance between the impeller and the casing is much less initially, and as it further moves the diameter increases or the distance increases. So this is called as volute casing, and the significance of the casing is that when there is less area or distance between the impeller and the casing, what happens is that the velocity of the water flow will be higher, and as it moves further the velocity decreases and the pressure increases as the area increases thereby. So at the end you can see here we have maximum area of distance between the impeller and the casing, so the velocity decreases or there very much and the pressure increases and a high pressure delivery is occurred. You can see now or there the impeller is rotating and the water enters the impeller as it rotates and it moves outside to the delivery. You can see the pressure is increasing over there as the delivery happens, and that's the pressure gauge over there which is showing that, and the delivery happens towards the tank, the head tank. So that's simply how a centrifugal pump works. I